Hello everyone. Today we are going to see why must every year have a Friday the 13th. And to do so, we are going to take the help of a mathematical tool which is called Modular Arithmetic. So first, we will learn what is the concept of this modular arithmetic, and then we will see how we can use it to prove that every year should have a Friday the 13th. So in order to do so, first we will have to define some basic things. First, you see that there is this big blue wheel which is numbered from 1 to 30, which represents one day of a standard month of 30 days. And we are going to call it the month wheel. And inside that, there is this green wheel which we are calling the week wheel, where each of these spokes have one day of the week named in it. So if the first day of that month is a Wednesday, then a passage of a particular day means this blue wheel and this green wheel rotates by a certain amount. Same for another day. And say the third day of this month is a Friday and we want to go past 1 month, then this month wheel will rotate once, whereas this week wheel will rotate 4 times and then a little bit. So we see that this wheel has ended on a Sunday, and actually the day has moved from a Friday to a Sunday after the passage of one full month. So 2 days has gone by after the passage of this month of 30 days. So where is this number of 2 coming from? If we break down 30, we see 30 can be written as 4 times 7, that is the 4 weeks that have gone by, plus 2 additional days. So this is the extra amount that the wheel has rotated to get from Friday to Sunday. So this 4 weeks means Friday to Friday, and then 2 days means that Friday to Sunday. And this can be written also in another form which goes like this. And this is actually read as 30 is congruent to 2 mod 7. So this 2 is coming from this leftover 2, and this 7 is coming because we are dividing this 30 into 7 equal segments, which were the weeks that we were talking about. So in other words, if we consider this 30 days separately, 30 is congruent to 2 mod 7 means that this 30 can be divided into 4 weeks, where each week has 7 days, and after that 2 days will be left. Another way of looking at this is through long division. So if we take 30 and divide that by 7, we will see that we are getting a remainder of 2, and that is where this 2 is coming from. And likewise, if our month had 31 days, then 3 such days would get left behind, and we would write 31 is congruent to 3 mod 7. And if it was a February of a non-leap year, which had 28 days, then there won't be any day left over, and we would write 0 mod 7. And this is evident from the fact that 28 perfectly is divided by 7, so that there is no remainder left. So with this knowledge, let us try to do something, and let us try to find out that given that 16th August 2021 was a Monday, to find out what day of the week it will be on 16th August 2022. So from 16th August 2021 to 16th August 2022, there are 365 days, and we want to find out the modulo of 365 mod 7. So we divide 365 by 7 to find out that the remainder is 1. So this whole thing can be written in this format, that 365 is congruent to 1 mod 7. And so this 1 means that there are certain number of weeks hidden between 16th August 2021 and 2022, and then 1 additional day. And this 1 additional day takes it from Monday to Tuesday in the next year. To verify this, we look at the calendar of 2022 to see that indeed August 16th of 2022 lies on a Tuesday. So a few more words on how this arithmetic works. So 365 is congruent to 1 mod 7 means there is 1 day left excess after going through the 52 weeks. So if we go up by 1, there is now 2 days excess instead of 1 that was previously there. And likewise, if we go up 3 mod 7, 4 mod 7, 5 mod 7, 6 mod 7, and 371 is 7 mod 7. But there is another way we can write this. This 7 can actually go inside another such full rotation of the week wheel, and this finally can be written as 0 mod 7, where this final rotation has been incorporated into the rotations of the week wheel. So equivalently, it could have been written as 0 mod 7. And if we go up by one more day, 372 originally was 8 mod 7, but this 8 could be broken into 1 plus 7, and this 7 can go inside this 52 to make it 1 mod 7. So we see that in this kind of mod 7 setup, the numbers are going from 0, 1, 2, 3, 4, 5, 6, and then again coming back to 0, 1, 2, 3, 4, 5, 6. So with this in mind, we go on to show that this current year, 2021, had a Friday that was the 13th. So if we look at the calendar for the month of January and we look at the 13th day, it was a Wednesday, and that is shown here in this month and week wheel, that this 13th was a Wednesday. And now we will look at the 13th of each consecutive month to see what day of the week it was, and we will use our tool of modular arithmetic to actually find that out. And for that we will actually convert the days of the week into numbers. So now Sunday is a 0, Monday is a 1, and likewise. So this is how the week wheel looks in this new setup. So you see that right now it's on a 3, and 3 means it's a Wednesday. That is what we saw earlier. And our goal is to show that for at least 1 month of this year, the 13 of the month wheel corresponded with the 5 of the week wheel, which is a Friday. And that would give us the Friday the 13th that we were looking for. So we start at the January 13th, the first month, which was a Wednesday, and that is represented by this number 3. So January 13 is 3 mod 7 because we are starting at this Wednesday. To go, and we should remember all this while that these 3 numbers has this representation in mod that we already calculated. Just as a reminder, 28 is 0 mod 7 because 28 can be exactly divided by 7 and no remainder is left. So to go to the next month, from January 13th to February 13th, there are 31 days, and to find out what mod 7 that day will be, we just look at this chart here and we see it's 3 mod 7. So 3 gets added to this already 3. So this Wednesday corresponding 3 will become 6 when we are going to this February. And if you remember the previous chart, this 6 was actually a Saturday. So February the 13th would be a Saturday. Now we go to the March 13th and we use this same trick to find out what day of the week it was on March 13th. And we see that because February had 28 days, we add 0 to this number 6. So again, March 13th is a Saturday by this calculation. For April 13th, we add 31 days from March. That is, we add actually 3 to this number, and 6 plus 3 is 9. But if we can break this 9 into 2 plus 7, and this 7 will go inside this mod 7 to make this 2 mod 7, resulting in a Tuesday. And we can play this game again for March to get 4 mod 7, for May to get 4 mod 7, then for June to get 4 plus 3, that is 7 mod 7, which is 0 mod 7, then July, which would become 2 mod 7 because June had 30 days, which is 2 mod 7, And finally, we will see that for August 13th, this is 2 plus 3, and this 3 is coming because July had 31 days, which is 3 mod 7, to get a 5 mod 7. And we have seen that this 13th day of the month is corresponding to the 5 of the week wheel, which is the Friday. So we have shown that 2021 indeed had a Friday the 13th. But now, how to prove this for every year? To do that, we will take the help of this chart where we have written down all the months along with number of days of that month, and we will find out what day the 13th of that month would be. And since we are trying to do this generally and for not any year, we will use this variable k to represent what day we are talking about. And this k can take a value from 0 to 6, which would correspond to each day of the week. And again, we will always remember this chart, which we previously used, where for the 3 possible months, the congruent modulos are calculated. So since we are doing this from a general perspective, let's consider that January is k mod 7. That is, this first day is this some kth day from this table. And if we go back to the 2021 case, this k was 3, which was this Wednesday, because the January 13th was congruent to 3 mod 7. And now we will do the same operations that we were doing, but with this number k. So for February, from January to February, there were 31 days. That means 31 is again 3 mod 7. So now 3 will get added with this k. So we will get k plus 3 mod 7. From February to March, there are 28 days. 28 is 0 mod 7. So 0 will get added with this k plus 3 mod 7. From March to April, there are 31 days. So the 3 will get added to k plus 3 mod 7. So we will get k plus 6 mod 7. From April to May, there are 30 days. So 2 will get added to this. So this will become k plus 8. But remember that 8 is 1 plus 7, and that 7 will get gobbled up by this mod 7, and we will be left with k plus 1 mod 7. So if we continue this, we will find that for the other months, these are what is the values of the congruences. And now we will see for each of these values which month for that year is corresponding to Friday the 13th. So say the month for the January 13th of that year, it was a Sunday, so that is k equal to 0, and we then plug k equal to 0 for all the numbers in this chart, and we see that the September of that year would have been Friday the 13th. If the January 13th had been a Monday, that is k equal to 1, we will see that the June of that year would have been would have this Friday the 13th. And interestingly, if the 13th January of that year was a Tuesday, we would actually get 3 Friday the 13th that whole year, and that would correspond in February, March, and November. And if we continue this, we will see that for the Friday the 13th to be a Wednesday, Thursday, Friday, or Saturday, there is at least 1 month where we are getting this Friday the 13th. So from these considerations, we have shown that whatever year it is, there will be a particular month which has a Friday the 13th. And we have shown this for the non-leap years, and you can try it for yourself with leap years to see that this also is applicable for those years. Thank you.